Um, we know in general, we've talked about domains a lot the past week, week and a half. So we know that if it has a fraction, what can't happen? The bottom can't be 0. If we have a square root, what has to be true?
Has to be greater than.
The thing under the radical has to be greater than or equal to 0. If it doesn't have either of those things, what's your domain? Negative infinity to positive infinity. So there's quite a few on this MathXL that ask you for domains, but a lot of them are really simple because if it's just a polynomial, if there's no radical and no fraction, it's an automatic negative infinity to positive infinity. Now with the compositions, we have to look a couple different places. There are two parts. We need to find the domain of the inside function. And the domain of the final answer. If you're trying to use MathXL to help you on these, when it says help me solve a problem, it kind of has a very different process, and it's a little more drawn out. So this is what it boils down to though. When we plug something in, if I put in a value for x, it has to work for the inside function, because that's the one you put it in first, and it has to work for the final answer. So we will combine these two pieces to get our overall domain. So let's take a look at a few. All right, we did compositions yesterday, so if I ask you to do g composed with f, that means g of f of x. So where do you start? F. F is x squared plus 3x minus 1. And what do I do with that?
Put it into the x on g.
Right, I'm going to plug it into g. So 2 times this plus 3. So that gives me 2x squared plus 6x plus 1. That is the composition. For the domain, you have to combine two different pieces. You have to look at the inside function and the final answer. We have to put those together when we're looking at the domain. When I look at this inside function, what can x be?
Anything.
Anything. There's no fraction, there's no radical. What about this one? Anything. When our original functions are just polynomials, we don't have to really worry about it. So my domain, we look both places, neither one has a fraction or a radical. So my domain is just an automatic negative infinity to positive infinity. So let's try one that isn't as nice. All right, I want the domain of f composed with g. So that's f of g of x. So g is 4 over x minus 1. All right, this is going to be kind of gross. So I plug that into f, so we get 1 over 4 over x minus 1 plus 2. Is this proper notation? No, we can't have a fraction in a fraction. There are different ways to get rid of this, but the fastest is when I look at this, I see I have an x minus 1 in the denominator. So I'm going to take everything times x minus 1. So the top and the bottom. So 1 times x minus 1 is x minus 1. 4 divided by x minus 1 times x minus 1, what happens to the x minus 1? cancels and leaves me with a 4. Then I have to take 2 times x minus 1. So what's that give me?
2x minus 2.
So we get x minus 1 over 2x plus 2. That's my composition. Now I want the domain. We have to look 2 places. The original inside and the final answer. So we have to find the domains of each of these things and then combine them. With the original, 4 over x minus 1. Okay, we know that in a fraction, the bottom can't be 1. So right here, I know x cannot be positive 1. Does everybody understand where that came from? So then when I look at the final answer, 2x plus 2 can't be 0. So x can't be negative 1 for this. So that's telling me if I want this problem to work, I cannot plug in a positive 1 or a negative 1. So we have to put those together for our domain. A couple different ways you can write it. I'm pretty firm. We've been doing interval notation on everything. The interval notation for this is a little bit uglier. So I will allow you to write it a couple different ways. If you have more than one value that x can't be, I will allow you to just say x cannot be negative 1 or positive 1. So the only time I'm going to allow this is if it's more than one thing that x cannot be. If you were to write this in an interval, what it's saying is it's everything except those numbers. So it's everything smaller than negative 1, between negative 1 and 1, and bigger than 1. So the interval actually looks like negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. But this is the one scenario where I am not going to require the interval. We can just list it. Questions on that one? Let's try. We'll do another one kind of along those lines. So this time I'm asking for G composed with F. So F is 3 over x minus 1. If I put that into G, I get 2 over 3 over x minus 1. So what's my shortcut for getting rid of that? So on the top, we get 2x minus 2. On the bottom, the x minus 1's cancel and just give me a 3. So that's my composition. Domain. We look 2 places. The original inside and the final answer. So for this, what can x not be? All right, what about this one? Right, the bottom can't be 0, but does 3 ever equal 0? No, so you could really plug in anything. So when I put these two together, this one can't be 1, that one can be anything. It's everything except 1. Is this okay with everybody? Let's try. Can I skip to this one? Is that okay? Can I just ask you, if I don't even work out this example, can you look at it and tell me what your domain's going to be? Negative infinity, positive infinity. There's no fractions, no radicals, so it's going to be everything. Let's do this one. It's a little bit, kind of involves everything. We've got a fraction, we've got a radical, so it ties it all together for us. So I want g composed with f. So g of f of x. So f is the square root of x plus 2. If I put that into g, I get 2 over the square root of x plus 2. Is it proper notation to leave a radical in the bottom? So what would you do?
Multiply by x plus 2.
You just squares.
If you had an equal sign with a number on the other side, you could square. Since we don't, we'll just multiply by the radical on top and bottom. So it gives us 2 radical x plus 2.
So pretty much we have flip.
Actually, you don't, because when you multiply these two together,
It just cancels out the square root.
yeah. Okay, so 2 places we have to look: the inside and final answer. So when I look at this inside, if you have a radical, you know the thing underneath has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. When I look at this one, it also has the radical, but we've already kind of figured that part out. It has a fraction, so we know in a fraction the bottom can't be 0, so x can't be negative 2.
So we're gonna just be
Well, everything but negatives.
Yeah. This one was greater than or equal, but then I'm saying, well, it can't be equal, so if you just take away your equal to, it's x is greater than negative 2. So
Negative 2.
negative 2 to infinity. Is this okay?
Yeah.
So there is a Math Excel assignment.